and those who are pathogenic, then they are antibiotic resistant, and it's made by the Actinomycetes, Streptomyces nivis. Does antibiotic novovirus have other name? Aisha? Does antibiotic novovirus have other name, Aisha? Say yes.
Yes.
Okay. What is the official name? Novovirus. But there is some other name, right? Who discovered that thing? Say I don't know. Okay. When it is discovered? Mid of 1950. Who made this thing? Actinomycetes. Name Streptomyces nivis. What it is? It is bacteria? Is it a bacteria? Asha? Say no. What it is? It's a Actinomycetes. Okay? And remember Actinomycetes? It's a branch bacteria. Fungus-like bacteria, right? Okay. So, why do we use novovirus in our test? To differentiate sensitivity of the cocci, right? Some of them are sensitive, some of them are resistant. To differentiate the skin cocci. You remember we saved our plate yellow colony and white colony? So I told you those who have the yellow colony, there is a chance that yellow colony might be dangerous, right? How do we know it is dangerous or not? By doing novovirus test. If it is novovirus sensitive, even the color is yellow, it's okay. If it is novovirus resistant and color is yellow, then it is dangerous, right? So we use in the lab to differentiate cocci, to differentiate pathogenic bacteria between the thing. So we use to see the resistance pattern, we like to see the sensitivity pattern, right? So all of these are the function of novovirus in our lab. Asha, if you feel anything bad, stop me, we may stay here up to 12, no problem. If you feel anything bad, if you think you cannot answer the thing, stop me, try to understand the thing. Don't just listen. Okay? Yes.
Are we discussing from last class?
Are you discussing?
Because I don't understand where we got the Streptomyces. So is it from
Okay.
last class?
You did not get it because it is not written in anywhere. Only I am the person who knows this thing.
Oh.
The last class we need to do two different tests. Novovirus test and coagulase test, which we did not do due to the snow day makeup.
How do you spell novovirus?
But I show you the plate. I show you the result. The novovirus is an antibiotic disk. It is an antibiotic. Okay?
How do you spell it?
Huh?
How do you spell it?
How do I novovirus? N-O-V-O. This is the novovirus.
You said it was discovered 1950.
Mid 1950. And who discovered it? Asha? Say I don't know.
I don't know.
Yes, that is the answer.
No one knows?
No, nobody knows. Okay. Any more question about novovirus? There are?
So
Yes.
it's used to differentiate the sensitivity of cocci to see the resistance and sensitivity?
Not to see that. We need to use novovirus to see whether the cocci bacteria is resistant or sensitive. Do you understand why you are looking for that thing? Because it is very important to get conclusion whether our skin bacteria is dangerous for us or not dangerous for us.
And you said yellow?
Yellow bacteria probably poisonous or infectious. So it is the confirmation test is coagulase test and novovirus test.
Okay.
This is the yellow colony. This is the yellow colony from your skin. From your skin. So we may conclude it is dangerous or it might not be. So which one it is? There is two possibilities. So we have to identify that thing, right? There should be only one, right? But the possibility is two. So therefore, we do this bacteria no biosyn test. So if it is sensitive, there is a clear zone. So then it is what, Aisha? No, sorry. It is good. And if it is resistant, it is bad. Does that make sense?
Yes.
And this antibiotic novavaccine made by an actinomycetes named Streptomyces nivis. And the first time the antibiotic discovered in mid 1950. And who discovered this thing, we don't know. But we call them novavaccine, but there are some other sweet name here and there. But we don't care now, because novavaccine is the official name. But they do have different name in past. Okay?
So
yes.
what's the coagulation test?
Huh?
Sorry.
Yes, no. Keep going.
So Novobiocin is made by
Actinomycetes name Streptomyces nivis.
How do you spell actinomyces?
Actinomycetes, okay?
made by actinomycetes. That's okay. So it's made by actinomycetes. And that's the norovirus?
You what? Russell?
Actinomycetes.
Actinomycetes is a filamentous bacteria.
Filamentous.
Okay. Streptomycin is an antibiotic, right? We use in our step gradient plate. You remember, we make one plate, green color and yellow color. Okay. So, the streptomycin, why do we use the streptomycin? We use the streptomycin to screen out the streptomycin resistant population present in natural population of E. coli. You remember that we made one plate. Here is the yellow part, here is the green part, right? Green part means contain antibiotic streptomycin, right? That we remember you make the plate, one is yellow, one is green stuff, right? So what is the green stuff tell you? Green stuff tell you that this part contain the antibiotic streptomycin, right? So why do we use antibiotic streptomycin here? And then what we do? We do stick the E. coli throughout the plate, right? And next class, here more growth, and here one or two growth. Why there is less growth? These are the growth, they grow in the presence of antibiotic streptomycin. So that means they are the resistance against this antibiotic. So from where this resistance come? Naturally, because E. coli population always make some antibiotic resistance pattern. Okay? Now, then the thing is, does this antibiotic make that antibiotic resistant bacteria? Asha? Say no.
No.
No. So, that is not the purpose. Why do we use streptomycin in this experiment? To screen out there is any streptomycin resistant bacteria present or not. Right? If you give me the food, if I eat that food, that means I love that food, right? But food cannot make me to I love or not love, is not that thing. You want everybody understand this thing? And the green color, what is the significance of green color?
It says streptomyces.
It shows us which location has antibiotic. Two color means, yellow means no antibiotic. Green media means has antibiotic. What is the name of the antibiotic? Streptomycin. Adam, please talk. Please talk. Yes. Yeah.
Okay, so the for the I forgot my question.
Yes.
For the novobiocin, you mentioned coagulase test. What is that for?
Coagulase is a different test.
Okay.
Coagulase is the enzyme. It make fibrin to fibrinogen. That's a different experiment. You remember the test tube, glass test tube, black cap? We put there for false. I showed you if the liquid becomes solid, that means bacteria make coagulase enzyme. If bacteria make coagulase enzyme, then it is dangerous.
Okay.
All the things present on that yellow bacteria from the skin. There's a possibility. Therefore, we do coagulase test and novobiocin test to confirm that our Staphylococcus aureus present in our skin is dangerous or not. You saw some of your plate is very nice yellow, so many yellow colonies, right? I told you change your soap, right?
Yeah.
Because don't take risk, and some of us the white colony. White colony is a friendly bacteria, no doubt. But yellow, they may be friendly, may not be friendly. So the best way to do to check other conformation test.
Okay.
Novobiocin and coagulase is a confirmation test that yellow bacteria do pathogenic or not.
Okay.
Okay,
Yes.
I remember. So for the green one, or for the
Step
resistant-
gradient plate.
resistant
It is
bac-
called step gradient plate.
strep gradient.
Yes.
And for the bacteria, where is this bacteria coming
gradient.
from?
Step.
Bacteria coming from
STEP.
a bacterial tube.
E. coli?
It is E. coli.
So E. coli makes resistant?
So that is the question that we have to ask. So what is the function of this antibiotic in this experiment? In this experiment, we use antibiotic streptomycin to screen out that this tube do or doesn't contain any resistant bacteria or not.
Okay.
So if they have the thing, how do that resistant bacteria grow here? Nobody knows. We just screen out, we just see they are present or not present. If they are present, they will give some growth in the presence of antibiotic. If they are not, you do not see any growth in this green portion. So streptomycin cannot make that mutate. Streptomycin help us to screen out, to find out they are present or not.
Okay.
Asha, understand?
Yes, sir.
Step gradient plate? I don't think so, but it's still okay. If you say yes, I would like to see you are asking a lot of questions. Okay? I intentionally ask you the thing and getting the answer from you, so therefore you don't need to study at your home. So if you take that advantage, that's fine. If you not, that's also fine. Okay? Okay. So what is the meaning of that green color? Show me. In the step gradient plate,
It contains this.
is indicate that that portion of the media contain the antibiotic streptomycin. That is the meaning of the green color. Okay? Okay? In plaque assay, we see, you remember the plaque assay, we put the 1 ml of virus and the solid liquid agar and put it in, and we saw some zone like this, clear zone, right? And they are called plaque. Plaque means they are the virus growing here. So how do this plaque happen? Because where there is no plaque happen, we have the growth of bacteria, E. coli, right? So what is the function of E. coli here? E. coli serve as a host of the virus T4, right? And the virus is killing here the E. coli, so therefore there is no growth, therefore we see some hollow zone. That means the virus is there. And we count the virus and we calculate back, and this time we don't need any compensation factor because we use 1 ml of virus. In bacteria cases, we use 100 microliter of virus. So that is the difference, right?
So-
Asha, do you understand?
No.
Okay. So, do you remember the plaque assay?
Yeah.
One day we dilute the virus, T4 virus?
Yeah.
Second time, we dilute the virus. Okay. And then we take 1 ml of virus and take some media, put in the water bath and mix together and put immediately and mix together and then put back to the incubator. And the next day when we come, we try to look for some clear zone, and that clear zone is called plaque. Plaque means the viral colony. Do virus possible to grow in lab?
No.
Say no. No. So then how do we know the virus here? Therefore we put some guinea pig here. The guinea pig name is E. coli. So E. coli we put them to kill by virus. So if they kill by virus, then there is nothing grow there. And if there is no virus attack, we saw a nice sheet of bacterial growth.
So the plaque is the clear zone.
Yes.
And
that is the viral growth.
viral growth.
Yes. So what do we use in plaque assay? We use TSA plate, right? This agar plate TSA plate. We use T4 virus. We use E. coli. We use liquid agar. And we put the liquid agar on the top of the solid agar. Therefore, it is called what is called?
Semi-solid?
Semi-solid experiment.
Okay. Wait. No. Okay, I'll ask anyway. So if you had a clear zone, that means that the viral grows. That means that E. coli died.
Yes.
Okay. And E. coli was spread all over the.
Yes. What we do? We put. This is a plate. What plate?
TSA plate.
TSA plate. Aisha, like her. Talk, please. TSA plate, right? And we put in one tube 1 ml of T4 virus and plus 0.2 ml of E. coli. If you can remember the experiment. And then we put everything on this thing and swirl this thing and put in the incubation. So, therefore, the virus and bacteria both can grow in this media. So, if bacteria is not attacked by the virus, they are nicely grow here. And if the bacteria is attacked by the T4 virus, they make some clear zone. That is called plaque.
Okay.
Aisha, in plaque assay, why do we use E. coli?
To see where the bacteria. If the
The answer is to use as a living host. Because virus cannot grow without living things, right? You have to provide some guinea pig to see virus is attacking or not. That E. coli is a guinea pig or living host, right? Okay. So, what is the advantage of membrane filter method? One, it is fast. It is accurate. We can handle a large volume of liquid. We can capture a small number of bacteria, and it is fast accurate and used with liquid media. And tell us about the potable water. What is the potable water, Aisha?
It's drinkable water.
Drinkable water. What is the microbial quality of the potable water?
No.
0 parts per 100.
Zero. What is that?
0.1.
0.1 what? US standard. Zero fecal coliform per 100 ml of water. Right? Okay. Remember the Snyder test? The green.
Wait. I can't understand what.
If you understand, ask the question. I will tell you.
What were 5 and 6?
There is no 5 and 6. That's the
Like,
point.
the
It is used for with the liquid things, right? You can get liquid thing as contamination or not, and it can use to see the water is potable or not. So what is the potable means? It can tell you if there is a fecal coliform per 100 ml of water, then it is not potable in US standard. If there is one coliform, then it is not potable or not for drinking. Potable means able to drink.
Can you tell me the USA standard again?
US standard is 0 fecal coliform per 100 ml of water. If you go to Canada, it is 1 fecal coliform per 100 ml of water. If you go to Mexico, it is 2 coliform per 100 ml of water. Still it is okay to drink.
That's why you don't drink the water.
So you are fortunate enough that you live in USA. Do you remember the Snyder test? You put the tooth swab and put the stick there. It's a green colony, right? It's a green media, right? And next day, if 24 hours it become yellow, that means your mouth has 2 plaque forming bacteria. Lactobacillus lactis, Streptococcus, I don't know what is the other name, it is in the handout. Okay, so that is the thing. So this media, the Snyder media, green, right? It is rich in sugar. Does it make sense? Because the bacteria species here grow, the Streptococcus mutus and something, whatever the bacteria grow there, we are looking for 2 different bacteria, Lactobacillus and Streptococcus. Both are love to grow in sugar. Because if you put more sugar concentration, normal bacteria cannot grow in that high carbohydrate concentration. But these 2 bacteria can grow and the media become, green media become yellow within 24 hours. That means your mouth has that 2 bacteria. You have to take care nicely. Either you have a very great chance to make the plaque or the dental caries, right? Taylor, do you think you can talk a little bit?
Yeah.
Okay, let's see. I have a very last chance to talk with you. Would you please talk a little bit?
Yeah.
Okay. Marcella, would you please talk a little bit?
Okay.
Okay, thank you. So, which media you use for your throat swab?
Blood agar.
Throat sample go to blood agar. And skin sample? MSA. And what the outcome of skin microbiota in MSA? It may be white, right? It may be yellow. It may be white and yellow. It may be come from the skin on MSA plate. Is it true? Hadar? Is it true?
Yeah.
Okay. You remember in the PCR, we do the PCR small 3 tube. You remember the small 3 tube PCR thing? And that tube we use a Taq polymerase. So the purpose of the PCR to amplify the DNA, right? So amplify DNA means DNA replication, right? So DNA replication need an enzyme. It is a polymerase, right? So we use in the PCR, the temperature is, first temperature is 94 degrees C, second is 52 degrees C, third is 72 degrees C. So you see all of the temperature is higher than our body temperature. Is it true?
Yes.
What is our body temperature?
37.
37 degrees C. So even though, so if you use human polymerase, do you think they can work in 94 degrees C?
No.
No. Therefore, we use Taq polymerase. Taq polymerase come from a bacteria. Bacteria live in hot spring. What is the temperature of that hot spring?
100.
And what is the name of the bacteria? Thermus aquaticus.
That's pretty.
Yes, of course it is pretty.
Thermus aqueous. Aqueous.
The two different species in standard test. One is lactobacilli. Another one is streptobacilli. So, do you remember the UV damage, the Serratia marcescens?
Yeah.
So, how do the UV kill the bacteria? They make thymine dimer. If you have a DNA, T, A, C, T, T, G, and A, T, G, A, C. So, this kind of DNA is possible, right? Okay. If UV come here and they saw two TT seeds side by side, they make thymine dimer. That is the mechanism of damage of UV. And there is a gene in Serratia marcescens bacteria which make the red pigment, which is very sensitive to this UV treatment. Therefore, we make the UV treatment, and next class we will see whether or not the bacteria is still red or not. Because the bacteria is alive, but they lost to make the red pigment. Serratia marcescens in room temperature is red. So, by UV exposure, they should not be red.
So it makes.
Are you busy, Aisha?
I didn't understand, but if you can.
Which part?
This one.
Any of it.
Okay. Do you remember we do the UV test? We have three different plates, right?
Yeah.
We make the thick state of Serratia marcescens, right? And then there is a box-like thing under the hood, and there are some cardboard, something like star, moon, MC, something written there. We put upside down the plate here, and one is 3 seconds, one is 3 minutes. without lead, one is 3 minutes with lead. You remember the experiment, Aisha?
Yeah.
And then we put turn on the machine. So machine turn on means you are putting some UV. So the question is how this UV kill their bacteria. So the killing is UV pass through the DNA, right? Pass through the body of bacteria. If they saw the DNA and if they saw two thymine thing present in the DNA, they make thymine dimer. Normal thymine neighbor, Nika and Aisha sitting, suddenly they start fighting. That is the fighting and that is the normal. That's why they kill the bacteria by UV. That is the mechanism of UV. What is the wavelength of UV? There is a spectrum of light, right? So visible spectrum 400 to 700 or something. Around the 400, before 400, you will see UV here, and after 700, there is infrared. So the wavelength is 40 to 400 or something. You have to find out the wavelength of UV. It is 40 to 400 or something. That is your job to find out. What is the wavelength of UV?
Okay, so you said if there's a thymine, then the UV light.
And if that region see the exposure of UV, then that thymine, normal thymine become thymine dimer. A different structure. And that is the mechanism of killing by UV.
So it kills it, meaning that it would not show on the plate. So the outside would be red, but the part that will be clear. The part that's killed will be clear.
Okay, clear means what?
No growth.
Clear means that means bacteria is
Or dead.
dead. So most 3 minute exposure, it will kill some bacteria. For 3 second exposure, you will see some bacteria grow, some bacteria red, some bacteria white. Does Serratia marcescens white in the room temperature? Say no.
Red. No, it's red.
Say no.
No.
No. So why, from where that white colony come? The white colony come because they have exposed to UV, and UV can kill the red pigment containing gene. Therefore, they cannot die, but they are defective. Defective means they cannot grow as red in room temperature.
So it's not dead, it's just defective?
Of course, what do you think?
I thought it was dead.
You think it is dead?
I thought so.
First time you say there is some no growth. That is the dead.
Uh-huh.
So growth with different morphology. What does that mean?
It's a large.
They somehow survive,
Uh-huh.
but defective survive, right? They cannot express that red protein making gene. Why they cannot make? Because UV can damage that gene. Asha, what about you? Do you think she try to understand? You try to understand?
Yes.
I don't think so. Okay. What is the meaning of PCR? PCR is the abbreviation, right? It is called polymerase chain. It is called polymerase chain reaction, PCR. Okay, so please learn the name of the product which make Serratia marcescens red.
Say that again.
Learn. I don't think you saw the study guide or not. It is clearly written there, learn the name of the gene which can make Serratia marcescens red. It's a peculiar name. It's a big name. It's a big name, and the spelling is hard. You have to find it out from your handout, UV handout.
The study guide doesn't say that.
Okay, I am saying now. Study guide do say that thing.
Okay.
So you have to learn that thing, the name of that protein or gene. Okay, Aisha, can you please tell me, whenever I give you the unknown 2 bacteria, in what form? Taylor, I give you unknown 2 exam, right? In what form? Heather, in what form?
So which one?
Unknown 2. Vera, how do I give you unknown 2? How do I give?
On a plate.
On a agar plate.
Agar plate marked A and B.
No, A and B I don't care. I give you 004, right? A plate. Aisha,
Yes.
how do I give you the unknown 2 bacteria?
On the other plate.
On the agar plate.
Yes.
What will you do after getting this plate?
We try to transfer it.
Number 1. What you try to do?
Try to transfer it. We label it A and B.
Okay. That is the, do you think it is an experiment? No, it is labeling, right? Okay, what you do in experimental basis?
Then we take the mark and the B plate.
So, you put in
First
MAC
the T
and
plate.
TEA plate, right?
Yes.
What next you do?
We label.
We have to stick TSA plate. Don't say label already done.
I thought we were going to label the plate like A and B.
What you think, try to think scientifically.
Okay.
And then what you do? You do
With the catalyst.
catalyst test. Any questions? By getting the unknown 2, the couple of first movement is like this, right, brother? Okay.
Wait, let's find it.
Taylor, whenever you got your unknown 2, what is the first couple of movements around that bacteria?
The first couple. What?
What?
What did you say?
Yes,
What did you say?
I say whenever your teacher give you unknown 2 exam, what is the first couple of movement you will do with that question? Heather, what is the first couple of movement?
The unknown.
Vera, what is the couple of movement?
Black test.
Shamin, what is the couple of movement?
Just treat TSA plates.
Then, One.
MAC and B.
very good.
And
Then,
catalyst.
make and P, and then,
Catalyst test.
yeah, okay. Vera, now repeat after her. What you do, what is the couple of movement when you get the unknown 2?
Oh, the MAC and the and then this street the TSA plate and catalyst.
Adults, now you understand?
Yes.
Okay, why not you tell one more time? You don't feel good, then it's okay. Say, ask somebody else. Okay. Amy, can you please tell what you do after getting that unknown 2 bacteria?
You label it,
Okay.
and then you get the MAC
This
and
time,
the PA,
this time you should.
and then you
want
do it's street. So the TSA from the TSA, and then you do the catalyst.
Why you stick on TSA plate?
I'm sorry.
Which one? You stick in TSA plate. Amy said so. I'm not saying. Amy said. Do you think it's okay?
Strict TSA plate.
Okay or not?
Yes.
So why?
To get the isolated, to get the single isolated.
No. Oh, what will you do single isolated colony?
To get the colony.
To get the colony, what will you do?
After unknown bacteria.
Okay. What about I show you? What is the purpose of that thing? Because we amplify the bacteria, because in the next day we need tons of bacteria to do the sucrose, do indole, citrate, urease, hydrogen sulfide, lot of bacteria we need. I give you a tiny stick, right? You have to amplify that bacteria to get more, to study and to get the name of your bacteria.
So to amplify it is the whole thing.
Not to. What do you think now?
To amplify.
Why you need amplification?
Because we need it.
We need lot of bacteria. So we make that structure. It is not the isolated colony. It's the opposite of isolated colony. Right? But the stick plate method, yes, the purpose is to get an isolated colony. What is the significance of that isolated colony? If you get single isolated colony, that clearly means you that the bacteria I give you or the exam give you is true, not contaminated. Only one bacteria is there. If you see one red colony, one yellow colony, that means your bacteria is contaminated. So if you can show that thing to your teacher, you don't need to do anything. You get 100% mark. You don't need to do Rubric 7 because you give me false question. That is the beauty of that, and that is the power of microbiology. So everything has a power. Hadat, why you deny to answer that question?
Because I couldn't hear it.
Oh, okay. So, you need 5 minutes break or I have to start?
5 minutes break.
Okay, that's fine.